Just watch. I'm going to do some rules that you guys learned. What is x to the 5th times x squared? So everyone knows the rule that direction. The problem is you guys got to know the rule this direction. We know that when we multiply with the same base, we add the exponents. So if I had x to the square times x to the triangle, that is x to the square plus x to the triangle, x to the square plus triangle. If you have the same base, you add the exponents. Are we good? But can you go backwards? If you have x to the triangle plus square, that's x to the triangle times x to the square. I got to work on my shapes. X to the square times x to the triangle, going backwards. And it's just think about it the same way, but you guys have learned in all your other classes going one direction, but we have to understand it in the other direction. What you're seeing is e to something plus e to something. So e to the 3x to the 4th plus c means e to that exponent times e to that exponent. But wait, before you write, what is e to a constant? Just another constant, so I can just call it like C1, and since it's a constant, I can just put it in front of the thing. So what we do is whenever we e this side, I go, well, e the constant is just another constant that I throw in front as a product. The problem that we have is students don't listen to me on this. They don't send the math, and they'll go like this. They think it means this plus e to the c, and that's bad math. That's not what it means. It doesn't mean plus, it means times. And then they'll just write this on the test. Every year I got 2 or 3 people that write that on the test and go, that's what it means. No, it doesn't. Because going backwards from your rule, when you multiply, you add. So if you're adding, you're multiplying, going backwards.
So it's necessary for the C1 to be in front?
When we write in front of an exponent, we multiply, we just put in front. It could be in the back, but as long as you know it's multiply. The problem that when people write in the back, they accidentally add. So usually we put it in front. So I'm always put in front, so I say consistent, but if you put a times, like a dot, and put it in the back, you're not wrong. Okay? All right, so we good? We're gonna see this like 4 or 5 times. This is AP's favorite. They love this guy, or at least in the past they did. All right, so now we're ready to find C. Now some people are like, can we send the 1 over first? You are totally fine in doing that, but I'm gonna find C now. All right, so let's find C1. All right, this time the C finder was 0, 10. So we're gonna plug in 10 for my Y. What's 10 minus 1? Hopefully get 9. And then I get C1. And what's e to the 0? 1. Some of you on the last test, e to the 0. Some of you put 0. E to the 0 is 1. Anything the 0 power has been 1 your whole life, it won't change. So what is C1? 9. All right. So I got 9 equals C1. So put 9 in. All right. Are we done? Or what do I have to do?
+1.
Huh?
+1.
+1. I have to get y by itself? Because I give you 4 out of 5 here. It's sad that you don't get your last point. So what would it be if I saw +1?
This y equals 9 times e to the power 3x to the power 4 plus 1.
Okay, good. Do not add those because I have people put, oh, 9 plus 1 is 10. No. You guys know those are not like terms, so you can add those. You guys, that's the original equation where the point 0, 10 works that has that as its derivative. Does that make sense? So what you guys are given is the derivative, the slope of the tangent line, and we're going, what was the original problem that had this point worked? If there was a different point that worked, the equation would be a different equation. There's an infinite number of equations out there. Every time I change the point, it would be a different answer. That's why a general solution would be with a C. Here's the infinite answers. As our C finder changes, our equation changes. Okay? So far, so good? All right, let's go to the next one. I got to race again. Can I race? All right. I know you guys weren't born. 2000. But here's why I still have this one in here. This is one of the first ones they asked to an AB class, but I mean, you can see it says BC number 6. So BC was our guinea pigs. So the AP test changed the test around 2000 and said, okay, slow fills are going to be taught, but we're going to make the BC do them first. So they said slow fills are going to be taught. So BC were doing them. So they said, those of you teaching AB, you guys, here's what the questions are going to be like. So they told us to study the BC release exams and put those in your notes and show your AB what they're going to be like. So I put that in my notes. This is the one that they asked in BC before they asked AB. Does that make sense? This is before they did it. So this is one of the first ones. I could have changed it by now, but I thought it was a pretty good problem. So it was a little different. So I've just kept it. It's unique. I'm trying to show you one that had the plus or minus the radical decision. So you have that in your notes, the E both sides decision. Those are very common AP. All right, so let's separate this one. Now this is your slope of your tangent line. Still very important. And let's separate. Whenever they ask you to find the particular solution, we have to separate. So what goes over here with dy? Hello?
Y minus 1 squared.
Say it again?
Y minus 1 squared.
Y minus 1 squared. That comes down here on the bottom. And what's on the right? X dx. Nothing really to do except bring the dx over. Pretty simple to separate. And you get 1 out of 5 points so far. I'll show you guys later, probably tomorrow. I'll show you the scoring and you'll see the note that they have saying, if students don't separate variables, 0 out of 5 points. And it seems harsh, but nothing else you do makes sense if you don't separate right. Like all the steps you write are gibberish. So they're going, I have nothing to give them. All right? All right, so once you separate, we're going to take an integral of both sides. Now the left side, I showed you this over there, is that we would bring this up. So I'm not going to, even though I could take the integral of the right side, I'm going to wait. I could do it now, but I'm just going to wait. So I've earned the 1 point, but I haven't done the integration yet. If you don't know how to take the integral of the left side, at least take the integral of the right side and get that second point, and there's nothing else you can do. You're like, I got 2 out of 5. You know, do your best. This one could be done by substitution. If you're not sure, substitution is always a good method, okay? But we can do it in our heads real quick. If you have a binomial to a power, since the derivative of the inside is just 1, you can add 1 to that power and divide by that number. Okay, and we'll have more discussion on this tomorrow. And on the right side, it's x squared over 2 plus c. Just want to make sure we have some more time today, so I'm going to go a little quicker today. All right, now, the left side. Clean this up. This is negative power, so it goes to the bottom. I can put the negative sign anywhere I want. That's what I'm seeing right now. Pretty ugly equation, but I still have to earn the last 2 points. I've earned 3 out of 5. I still have to find C. So look, if I can at least find C, I get that 4th point. If I get Y by itself, I can get that 5th point. So they gave me the C finder right here. So let's go ahead and find C. Do it wherever I want. Now, you'll understand why I have my students do it to the side. I used to have them just continue find C, right? My students would do all this work and find C. Then they didn't, once they got it, they didn't know where to go back. They go, where do I plug it back into? I go, when you started to find C, and they get so confused. So I said, okay, how about we just do it off to the side, and then wherever you left off, you put it back in, and my scores went up. So that's why I do it that way. You can do whatever you want. All right, so we plug in 0, negative 1. All right, plug in negative 1 over here for Y. What do you get? 1/2, good, good math. And then when I plug in 0, I get 0 plus C. So C is, so C is 1/2. So I can go back, see, I'll go back to where I left off. And I get 1/2. Sweet. Whew, 4 out of 5. And some of you might give up there because solving for Y is not the easiest thing right here. I don't want any of you to give up. That's not in our, hopefully our vocabulary.